Okay guys, I meant to put this at the end of the Stokes theorem lecture, but I kind of screwed up. So what we're going to do now is we're going to apply Stokes theorem to electric fields. And the main point is that we already talked about how the line integral around a closed path of the electric field is equal to 0, and that's independent of path. So we're going to learn why that means that Stokes theorem shows that the curl of the electric field is 0 everywhere. Okay, so if I go back to this lecture here, and I made this point that the curl is 0 here, even though, the total sum of the curl is 0 here, even though we do have some non-zero curl along the sheet. So I'm going to steal this guy, and I'm going to argue that our V here could not be an electric field. And the reason for that is when I do a line integral of an electric field, it is independent of the path. And the reason for that, I said, is because it should make sense to you that the electric force, which is what we base the electric field on from Coulomb's law, is conservative. Okay, so if you have this situation, okay, and the line integral of some field is independent of path, follow me here, the line integral is independent of path, then the line integral around any closed path must be 0. Okay, which is essentially to say that if I take a line integral, around some electric field, and the start point and the end point are at the same place, but I calculate some wonky line integral, it's got to be 0. Because the endpoints are the same. Okay, so if I look at this particular field, this one can't be an electric field, because if I were to just take the line integral around half of the sheet, it would be positive. Okay, so if I were just to take the line integral around half the sheet, I would get a positive value. Okay, so the point of all this is to be able to use Stokes' theorem to show that the curl of the electric field is everywhere, okay? So if I write out Stokes' theorem for an electric field, it tells me that if I take a closed path with the electric field around some loop, it's going to be equal to the integral of curl over some surface, okay? I'm going to argue that if this one is independent of path, then, which it is for an electric field, then our curl of the electric field must be 0 everywhere. Okay, and that's how we can use Stokes' theorem to say that the curl of the electric field is 0 everywhere.